Hello students, I am here again with a problem on fluid mechanics. Again it is a problem on hydrostatics basically, and it is based on liquid filled in a rotating cylinder. This is the question. A cylindrical container of base radius r and height h, the height of the container is h and radius of the base is r, is open at the top. The container is open at the top. It is completely filled with a liquid and set rotating about its central vertical axis. It is filled to the brim by some liquid, some opaque liquid which is not transparent, and it is spun like this about the central vertical axis. When the spinning angular speed is omega naught, the bottom surface of the container just gets exposed. When you spin the cylinder, liquid actually spills out of the cylinder. It is thrown out. If you go on increasing the angular speed, more and more liquid will be thrown out. At certain value of omega that is equal to omega naught, the question says that the bottom surface of the cylinder just gets exposed. That means you are able to see some part of bottom surface of the cylinder. Okay. This happens at angular speed omega naught, value of which is not given in the question. But now the question says, if the spinning speed is increased further to 2 omega naught, how much area of the bottom surface will get exposed? How much area of the bottom surface will be visible if you are looking into the cylinder from the top? So, how much area will be basically not having any liquid over it? That is the question. I am getting out of the screen so that you can capture the question and give it a try on your own. Do try it. Many of you, I think, will be able to do it also. So, here is the situation. Many of you must have studied that the actual surface of the liquid, the top surface of the liquid, is actually a paraboloid. But if I draw a cross section, then the liquid surface has a cross section in the shape of a parabola. If you revolve this parabola about this white line, you get the actual 3-dimensional surface. But okay, let us keep it to 2 dimension. This is the situation. If you are increasing the angular speed, liquid is getting spilled out, and at some angular speed omega naught, this is what you see, that complete liquid has been removed from the center. That means this part has become just visible. Why the liquid surface has become like this? It is not very difficult to understand. You have studied that if you accelerate a container which is filled with liquid, the liquid surface actually gets inclined. It is somewhat similar. If you are spinning it, there is an accelerated frame, and the centrifugal force in this particular frame tries to push the liquid outward. So, that ejects some amount of liquid from the cylinder, and the liquid surface, this surface is not a straight line, it is curved. This is yet to be proved. I will prove it in a simple manner, fundamental manner. There are many ways of proving it. There are many ways of writing the equation of this surface. I will take one fundamental approach. First, I will do that, then I will go on to solve the problem. Let us imagine a cylindrical element of liquid here at the bottom of the container. Students, please don't get confused. This is not a foreign object. I am drawing it here separately. It is just an element of the liquid only. Liquid is present here, right? And I am just imagining the motion of one cylindrical element of the liquid, right? How is it moving? This yellow colored cylindrical liquid, how is it moving? It is rotating like this as the container goes. This is white line. This yellow colored cylindrical piece of liquid that I am considering, and it is going around like this. So, you all know that if any object rotates, then there must be some radial force acting on it, otherwise rotation is just not possible. So, what I want to think is, who is providing the proper radial force to this yellow colored liquid element so that it can rotate. Let us assume that the area of cross section of this cylinder is delta S. I am considering a cylindrical liquid element. लिक्विड का ही एक टुकड़ा है जो मैं इमेजिन कर रहा हूं यहां बैठ के क्लास में, है ना. Delta S is the area, let us say. Okay, fine. And let us say length of this element that I have considered is x. Fine. For the sake of simplicity, I am ignoring atmospheric pressure, though you can take it, but it will keep my equation simple. Even if you consider it, it will have no other effect actually. So, I am just ignoring it. Let us say there is no air, there is no atmosphere, just for simplicity. So, here on this side, there is no pressure because here there is no liquid. The question says this place has been exposed, the bottom surface of the cylinder has been exposed, but here there is liquid. This liquid will exert force here. How much force? Pressure into delta S. If P is the pressure over here, right? Fine. So, on this cylinder of liquid, the net radial force that is acting is P delta S. P delta S. What is P? At this particular point, if I consider that height of the liquid is y, then what will be pressure here? The atmospheric pressure plus rho g y. I have not written atmospheric pressure, actually it will cancel out from both sides if you do write it, you can write it. So, I am assuming there is no atmosphere for simplicity. So, here the pressure is rho g y. If the depth here is y, then the pressure at this particular point is rho g y. So, this P is nothing but rho g y into delta S. So, this is the radial force that this piece of yellow colored piece of liquid is experiencing, and because of this radial force it is able to rotate like this. So, this radial force rho g y delta S must be equal to m omega square r, where r is the radius of circular path of the center of mass of this cylindrical liquid. Center of mass G. अगर मैं ऐसा लिख रहा हूं, if you just don't want to do any integration and all, you can think like this. If this rod is rotating with some angular speed omega, center of mass is a point that is rotating in a circle of this radius r. So, acceleration of center of mass is omega square r, and the force on this object must be mass times acceleration of center of mass. Force, external force on a body is mass times acceleration of its center of mass. So, if you are considering this yellow colored liquid element, the horizontal radial force that we see on it is only P delta S, which is equal to this much, and this is responsible for rotation of this yellow colored thing. So, this force must be equal to mass times acceleration of center of mass of this yellow colored thing. What is the acceleration of center of mass of this yellow colored thing? Answer is, this yellow colored thing has center of mass here right at the center, and this center of mass is moving in a circle of radius x by 2. So, I will write m. M means mass of this liquid, which is rho delta S into x. What is delta S into x? Delta S into x is volume. Volume into rho is mass. This is mass m omega square into x by 2. Why x by 2? Because center of mass is going in a circle of radius x by 2. So, I have written m omega square r, where r is the radius of circular motion, circular path of the center of mass. So, delta S cancels out, rho cancels out. If you consider atmospheric pressure, it will also get cancelled out. Here you will write atmospheric pressure into delta S is force, and here in case of pressure at this point you will write atmospheric pressure plus rho g y. It will get cancelled out, do not worry about it. So, here you can see that this simplifies to y is equal to omega square x square by 2 g rho. I am so sorry. Is it right? Rho cancels out. G goes here, 2 comes here, x square, delta S cancels out, and this is the equation. Okay, that's fine. So, y is equal to omega square by 2g into x square. Now, if I assume that this point is my origin of coordinate system, and this is x axis and this is y axis, then what do you think? What does this relation tell you? What is this relation actually? It is the equation of this blue colored curve. Why? Because this is origin, I move x distance along x axis and then I move y distance along y axis, I reach this point. So, actually x comma y is nothing but coordinate of a point on this blue curve. So, this relation is nothing but equation of the curve. So, y is some constant into x square, which is a parabola. So, this curve is a parabola. If you rotate it in 3 dimension, of course, it will become something like this, and that is how the water surface will look like. I hope you understand this. Okay. So, the question says when omega is equal to omega naught, then situation actually looks like this that I have drawn here. This point gets just exposed. That means vertex of the parabola falls over here. So, according to the question, value of y is h. H is a given number in the question, that height of the tank is h. Value of y is h when omega is omega naught. And at that particular instant, when value of y is h, x is r. When x is r, value of y becomes h. So, I hope you understand this. Question says that when omega is equal to omega naught, this gets exposed. So, this gets exposed means some liquid has been thrown out. If some liquid has been thrown out, then the liquid surface will become like this only. The liquid is at the brim of the container. If you increase the omega, more liquid will be thrown out. So, when value of x is r, value of y is h. H is a given number, r is a given number. So, if you substitute this, you get the value of omega naught. Omega naught is that angular speed at which the central point of the bottom surface gets exposed. Now, the question says that if you increase the angular speed further to 2 omega naught, how much area of this bottom surface will get exposed? That is the question. So, let us move on further. What actually happens if you increase the value of omega, then the slope of the parabola at every point will also increase. What is slope? Dy by dx. So, this is a constant into 2x. If you increase the value of omega, this parabola will get steeper, more steeper at same coordinate x. So, actually when you increase the angular speed, what happens is the parabolic shape will become even steeper. Just be with me for a couple of more minutes and everything will become crystal clear. Just be patient, students. This is the actual container. This is the actual container. White colored thing is the actual container. And the liquid surface will actually be like this inside the container. This blue colored thing, and this part will get exposed. Had the container been of greater depth, just imagine that container is of higher depth, such that at angular speed 2 omega naught, let us imagine that a container is there with us which has got higher depth, and at speed 2 omega naught, it just gets exposed, the bottom surface just gets exposed. So, if we were having a container of higher depth and we increase the angular speed to 2 omega naught, then the shape of the surface would become like this, just as we did the analysis just now. So in that particular case, for value of x equal to r, value of y will be y dash, which I do not know, but I have just deduced one equation that y is omega square by 2g x square. So omega square by 2g x square is r square. What I am saying is कि अगर मेरे पास ज्यादा गहराई का कंटेनर होता जिसमें 2 ओमेगा नॉट एंगुलर स्पीड करने से जस्ट सेंटर पॉइंट एक्सपोज होता, तो इसका मीनिंग क्या होता कि व्हेन x इज इक्वल टू r, वैल्यू ऑफ y इज इक्वल टू height of the container, isn't it? The same equation can be used. Now according to the question, this omega is 2 omega naught, so it becomes actually, if you put 2 omega naught here, it will become 2 omega naught square r square by g, and the value of omega naught is something that we already know, it is under root 2 gh by r. So if you substitute it, this is what you get 4h. What I am trying to say is, if angular speed is increased to 2 omega naught, then you will require a container of height 4h so that the bottom surface just gets exposed. So this helps you in visualizing the shape of the liquid surface. Actually our container is only up to this depth only, but had it been a container of 4 times the depth of given container, then in that case the liquid surface would have appeared like this. Okay, that's fine, but actually our container is only like this. So this whole thing will get exposed because the surface will go like this only. So what is the value of x here? What is the value of x here? The value of y at this particular point is 3h. I hope you understand. This is 4h and this is h, actual depth of the container. So this is 3h. So what is this value x when this y coordinate is 3h? I am taking this as origin, this as x-axis, this is y-axis. So I'll ask my equation when x is equal to, what is the value of x when y is equal to 3h? I hope you are getting my point. So the equation in terms of x is actually, the equation of the curve in terms of x is omega square by 2g into x square. So what I have done here is, I am asking the value of x when y is 3h and omega is equal to 2 omega naught. So y is 3h, omega is 2 omega naught, means it is 2 times 2gh by r square. Please do the necessary substitution, and I want to know the value of x. If you simplify this, you will get the value of x as 3 by 4 into r. So actual container is this, and it will have this much area exposed. This is a circle of radius x, x is 3 by 4 r. So you can easily write the area exposed. Area exposed will be pi x square. That is your answer. Because no, I made a mistake, I am so sorry. 3 upon 4, it will be root of this, I am so sorry. Under root of 3 by 4 r square. Now it is perfectly all right. Under root of 3 by 4 into r, that is the value of x. Please do the calculations. So the area that is exposed where we do not have any liquid is pi into x square, and pi into x square, x is known, you can write it as pi 3 by 4 pi r square. So of course a bit difficult question, but it is not something that you cannot do. Think about it. If you have not been able to understand, think about it a little more, you will be able to understand. I will just repeat in 30 seconds so that it may help you in understanding. If the cylinder is rotated such that, with an angular speed such that this particular point gets exposed, then the shape of the liquid surface goes like this. I have taken this as origin, this as x-axis, and this is y-axis. And considering that, I have written the equation of the surface as, the equation of that curve as y is omega square by 2g into x square. So, if you increase the angular speed, at the when this happens for a container of radius r and height h, the value of omega naught is this much. When y is h, radius is r, so you can calculate omega naught. Now, if you increase the omega further, and just imagine that you have much deeper tank, much deeper container. So, let us imagine that at some angular speed 2 omega naught, this is the situation in a deep tank. That means the bottom surface just gets exposed at angular speed 2 omega naught. Then this is how this situation will look like. अगर हमारे पास इतना गहरा टैंक होता, 2 ओमेगा नॉट स्पीड पे ये शेप ऐसा होता, ठीक, तो हमें ये पता लगाना है कि हमारी लिक्विड का कंटेनर तो एक्चुअली इतना ही है, तो यहां कितने एरिया में से पानी हट गया. यहां पानी है, यहां लिक्विड है, पर इतने एरिया में नहीं है. पानी का सरफेस ऐसा हो गया. पानी का सरफेस एक्चुअली ऐसा होता अगर हमारे पास काफी गहरा कंटेनर होता. तो मैंने ये सोचा कि कितना गहरा कंटेनर होने से ये पॉइंट जस्ट एक्सपोज होता. मतलब हमने जो अभी एनालिसिस किया था वो बिल्कुल वही एनालिसिस यूज किया जा सके. कितना गहरा कंटेनर होता. मैंने देखा कि भाई इस केस में x की वैल्यू r होने पे y की वैल्यू y डैश हमें हमारे इसी इक्वेशन से मिल जाएगा, क्योंकि हमें दिया हुआ है कि ओमेगा की वैल्यू 2 ओमेगा नॉट है. तो हमने y डैश निकाला, हमें इस कंटेनर की हाइट पता चल गई 4h. एक्चुअल कंटेनर की हाइट h है, तो ये डेप्थ एक्चुअली 3h है, जो कि है नहीं. तो हमारा लिक्विड का सरफेस बस ऐसा है. फिर से उसी इक्वेशन को यूज करके हमने y की वैल्यू 3h रख के ये x पता कर लिया, ये कर्व का इक्वेशन यूज करके. उससे हमें पता चल गया कि बॉटम सरफेस में जो एक्सपोज सरफेस है उसका रेडियस क्या है. Students, it was a bit difficult question. Even now, if you have some doubt, please write in comment section. I will try to help. Goodbye.